This is the June 2025 Edexcel, Pearson Edexcel paper 3. This is calculator paper, the last one of the series. Alright, question number 1, frequency polygon. So plot your points at the midpoints, the mid-interval values, and then join them up with a nice little dot to dot to create your frequency polygon. Nice gentle beginning. For question number 2, the mistake made is the step where they multiply both sides by 3 but didn't multiply the left hand side properly by doing 3 times p, take away 5. They're just multiplying the p by the 5 and not the negative 5 as well. So I've put he only multiplied p by 3 and not by the negative 5 as well. Full factorisation on b, so the highest common factor is 2xy, so it's 2xy lots of x squared plus 2y. Question number 3, so £25 for 200 oranges. Let's divide the 200 by 5 to work out the number of bags, that's 40 bags. Each bag's £1, so 40 bags equals £40. So that's £40 made, £25 spent. So to work out the percentage profit, we'll do 40 take away 25 divided by 25 times it by 100 to turn it into a percentage, and that's a 60% profit. Not bad. Question number 4. Lots of different ways of doing this one. I've just picked one of them. I've turned the London carrots and turned them into New York carrots, if you like. So taking the £3.75 divided by 2 to work out 1 kilogram, times it by 2.2 to work out 1 pound, that's weight pounds, and then times it by 1.2 to turn that into dollars. So the same amount of 2 kilograms of carrots costing £3.75 would cost you £4.75 in US dollars. Well, that's more expensive than the $4.90 for the same amount of carrots in New York. So New York carrots are better value. Question number 5, the bounds 23.75 to 23.85. Then question 6, a little trick, you can use the mixed fraction button on the calculator if you have one. So you can write 2 and 24/60ths. If you need to turn 24/60ths into a decimal and do it that way, that's absolutely fine. Anyway, it comes out as 630 kilometers per hour. Question number 7. The vector that takes us from A to B is 6, 5. And we know that B to C is half of A to B, so the vector that takes us from B to C is half of that, so 3, 2.5. So if I add 3, 2.5 to 8, 12, then we would get the coordinates of C. So that would be 8 plus the 3, and 12 plus the 2.5 is 11, 14.5. Alright, question number 8 with the trapezium. I have labelled the length from D to C as x, and we'll form a little equation for finding the area in terms of x. So for a trapezium, half the sum of the parallel sides times the distance between them, and do this you will find the area of a trapezium. So half of the sum of the parallel sides, that's 12 plus x, times the distance between them, that's 8, will give us 112. Half times 8 is 4, divide both sides by 4, we're left with the 12 plus x on the left and 28 on the right. Subtract 12 from both sides, x equals 16. We can, if we like, draw that 16. Because that length is 16 and A to B is 12, we have on that little right hand triangle I'm forming there, it's got a length 4, the difference between 12 and 16, and obviously its height is 8. And that allows us to construct a full expression for the perimeter. So we've got the 12, the 8 and the 16, and then we need the length C to B, so Pythagoras with our 4 and our 8, 12 plus 8 plus 16 plus the square root of 4 squared plus 8 squared, comes out as 44.9 centimetres. Question number 9, as an ordinary number, that's 5, 7, 3 and 4 zeros. And then in standard form for part B, 3.5 times 10 to the negative 2. And if you can push the correct buttons on your calculator in the correct order, you'll get 12.6 when you round it to 3 sig figs. Question number 10. Question number 11, using your indice rules, we're going to add together the n and the 20 and then subtract the 8. So 3 to the power of n plus 20 take away 8 is equal to 3 to the 14. Therefore n plus, simplify 20 minus 8, n plus 12 equals 14, n is 2. And for part B, that's going to be 16m to the 8. Okay, 10% of £440 is 44, but that's not what the 10% should be being applied to. It should be being applied to the original price. In this case, the original price would have been 400. 10% of 400 is 40. Add that on and you get the 440. Finding 10% of 440 is not relevant here. So I'm afraid, Jim, you are not correct. Okay, for part B, Tina selling her bikes. So we're reversing both percentages. So 180 divided by 1.5 sends us back a month to 120, and then 120 divided by 0.75, that's a 25% decrease. Takes us up to 160, which is the number of bikes sold in October. Recognise your graphs, just learn them. X cubed, E is a cubic, C is a reciprocal, B is the negative parabola, and H is the exponential. If you learn them, that's very straightforward. Half AB sine C for question 14, a half times 8.3 times 9.8 times sine of the angle between them, in this case 35. And if you can plug those into your calculator in the correct order, then you'll get an area 23.3 centimetres squared rounded to 3 sig figs. Question 15, it's with replacement, the pens are put back for the next pick. So there's two ways of getting at least two blues. You could get blue, 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 or you could get two blues and a red. For blue, 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 that's going to be 7 tenths times 7 tenths times 7 tenths, or 7 tenths cubed if you prefer, 343 over 1,000. When you get two blues and a red, there are three ways of doing that. You could get blue, blue, red, blue, or red, blue, blue. So I'm going to do 3 lots of this probability of there being two blues and a red. So 3 times by 2 blues is going to be 7 over 10 squared. And the red is 3 over 10. So the whole calculation for there being two blues and a red will be 3 times 7 tenths squared times 3 tenths, which comes out as 441 over 1,000. And I don't mind either of those for there being at least two blues, because there could be 2 or there could be 3. So I'll add those probabilities together. It could be 3 blues or it could be 2 blues and a red. Sum those two together, we get 784 over 1,000, which nicely simplifies down to 98 over 125, which is what the question wanted. There we go. Question number 16. So we've got a cone sat on a cylinder. Tells us that the volume of the whole solid is 640 pi. I'm going to label h as the height of the cone, that's what we're trying to find out, and that means the height of the cylinder is going to be h over 3. It's a third of the height of the cone. So my complete expression for the volume, well, let's do the cone first. A third times pi times 8 squared times h. And then the cylinder will be pi r squared. That's pi times 8 squared times the height h over 3, and that's going to equal 640 pi. Simplifying the cone, simplifies to 64 thirds of pi h. Simplifying the cylinder also simplifies to 64 thirds of pi h, and that's going to be equal to 640 pi. I chose this point, I could have done it before, but I chose this point to cancel all the pi's, add together 64 third h's to give us 128 thirds of h equal to 640, and then whatever way you want to work out h, divide by 128 thirds or times by 3 divided by 128, and you get your value of h, which is 15 if you've done it correctly. Question number 17, nice algebraic equation with fractions. So we are subtracting fractions here. We're going to need to get a common denominator. There are no common factors between the two denominators, so the simplest one is just multiply the two together. So I'll take the first fraction, multiply the top and the bottom by 3x plus 1. Take the second fraction, multiply the top and the bottom by 3x minus 1. Gives us a common denominator, and that's still going to be equal to 1. Now I'm going to expand, and I'm going to join these together as a single fraction because we have a common denominator. So I'm going to do 2 steps here just to save a little space. Expanding the first fraction, 15x squared plus 5x. Expanding the second fraction, be careful here with the minus sign, so you get a minus 6x squared, and then you're subtracting 2x times negative 1, so it's going to be a plus 2x. That's where most people will go wrong on this. Divide by 3x minus 1 times 3x plus 1, and that's equal to 1. All right, I'm going to do 2 more steps to take us to the next line. I'm going to simplify the numerator, and I'm going to multiply both sides by the denominator. Multiply both sides by 3x minus 1 times 3x plus 1. The numerator simplified to 9x squared plus 7x. I'm going to expand the right-hand side out now. If you expanded those out earlier on, that's absolutely fine. Expands out to 9x squared minus 1, and at this point, subtracting 9x squared from both sides, they cancel, leaving us with 7x equals negative 1. X is equal to negative 1/7. Question number 18, filling in the Venn diagram. Well, 32 is going to go in the middle. We know 15 people are going to go in the intersection between chocolate, coffee and hot chocolate. And then 43 people like coffee and tea, so we can work out the tea section. 39 like tea and hot chocolates. Essentially, you're just subtracting 32 from those numbers to get what's left. 67 like coffee, so we've got to work out that there's got to be 9 left in there. And the rest of them, you just got to work out these little puzzles. 17 left over because there's 100 in there. Then, for the conditional probability, we're given they like coffee, so we know it's inside the coffee, and the chances they also like hot chocolate. So we're looking at the 15 and the 32 there inside the coffee circle. So there's 47 in the intersection out of the 67 in the whole circle. So it's 47 67ths for B. Question number 19, upper and lower bounds. So the pile, we know that the height is 10.4, correct to the nearest millimetre. So that's going to be 10.45 as its upper bound, 10.35 as its lower bound. For the sheet of paper, its thickness 0.17 correct to 2 sig figs, so that's going to be 0.175 for its upper bound, 0.165 for its lower bound. To work out the number of sheets, well, I'm going to turn the sort of the height of the pile into millimetres by timesing it by 10 and dividing it by the number of sheets. I'm going to take the upper bound for the pile and the lower bound for the sheet to make the number of sheets as large as I possibly can. So I'm going to do 10 lots of 10.45. Which is 104.5, divide it by the 0.165, comes out as 633.3 recurring, and so the upper bound we're going to round that down to 633. 633 sheets is the upper bound. Question number 20, so OBC, it does say write down any circle theorems that you use, so do be careful, there are some keywords to look out for here. Starting with angle DOB is going to be 160. The circle theorem is the one that says that the angle at the centre is double the angle at the edge. The angle at the centre is double the angle at the edge. If you put the angle at the edge as half the angle at the centre, that would be absolutely fine. We do need to see words like double or half or twice, and it's got to be the angle at the centre and it's got to be the angle at the edge. Anyway, DOB is 160. DCB is going to be 100, and this is because opposite angles on a cyclic quadrilateral will sum to 180 degrees. Subtract 80 from 180 and you get 100. So the theorem I'm using there, opposite angles, and then cyclic quadrilateral. They're not that fussy about spelling, and that's going to sum to 180. And lastly, we've got 3 out of 4 angles in a quadrilateral, so the 4 angles will add to 360. So if I subtract the sum of the 3 angles I know from 360, it will give me the one remaining angle, OBC, which is the one the question wants us to find. This comes out as 57 degrees. Question 21, so these are non-linear simultaneous equations. To do this, we take the linear equation and we make x or y the subject. In this case, it's much more straightforward to make y the subject, otherwise you end up messing about with fractions. So y equals 2 minus 3x. Substitute that into the non-linear equation, so replace the y with 2 minus 3x. In that one, 3x squared plus 2 lots of 2 minus 3x squared equals 44. Remember to square the brackets first before multiplying by 2, rules of BODMAS. So double bracket expansion and then double each part of it, like that. And now we want to reduce it to a 3-term quadratic equal to 0. So how we solve quadratics, we make them equal to 0. I like to write them in descending powers of x, they're easier to deal with. If you spot at this point 21, 24 and 36 are all divisible by 3, we can simplify here. 7x squared minus 8x minus 12 equals 0. That factorizes quite nicely. You could, of course, use the quadratic equations formula here and get exactly the same answers. That would be absolutely fine. 7x plus 6 and x minus 2 gives me the two values of x to be negative 6/7 or 2. Now we know that y is equal to 2 minus 3x from the linear equation at the top, so substituting negative 6/7 and then 2 into that equation gives me the y values of 32/7 or negative 4. These solutions come as pairs, so I like to put a little box around them just to show that that's a pair of solutions there and a pair of solutions there. And then we're done. Question 22, you're going to have to put up with an appalling drawing that I've made here, but hopefully it demonstrates what the question is. I mean, that was supposed to be vertical and horizontal, and that's supposed to be a circle. I can only apologise. Alright, we get given the equation 3x minus 2y equals 52. I'm going to do a little bit of rearranging here just to get it into y equals mx plus c form. Y equals 3 over 2x minus 52. So it's going to look a little bit something like that. We know it's tangential to the circle, so it just skims it at the edge. We've got a point P where it skims the edge, and we can draw a perpendicular to our tangent that will go through the origin. The origin is, of course, the centre of the circle. The gradient of that new line is going to be the negative reciprocal of 3 over 2, so minus 2 over 3. It passes through the origin, so c is 0. So the equation of the second line is y equals minus 2 over 3x. And now we can solve our two linear equations simultaneously. I've just substituted y for minus 2/3 x, and then solve this in whatever way you want to. I've decided to make a common denominator of 6 here. I could have just multiplied everything by 6, whatever works here. A number of ways of going about doing that. Anyway, if you do it correctly, you'll end up with an x value of 12. And you can work out the y value of x is 12, y is going to be negative 8, and that gives us the coordinates of p. P is going to be 12, negative 8. Alright, on to the brilliant question 23. I wonder how many of you skipped straight to this question. The way I've gone about unlocking this one is I've found the vector m to p in 2 different ways. And by doing it in 2 different ways, it allows me to equate coefficients and use that to find the value of k. I have, just as a little aside, worked out the vector c to b, because that's going to be useful later on. C to b is going to be c to a plus a to o plus o to b. In this case, minus 2b minus a plus 3b simplifies to minus little a plus b. We'll just park that to one side for when it's useful. Okay, so the big strategy, m to p, finding vector m to p. 2 ways you can choose other vectors. You could do a to p in 2 ways. You could do o to p in 2 ways. I think m to p, I don't know if it's necessarily easier than the others, but the others are no easier than this one. So this is the one I decided to go with. Okay, so the first way from getting from m to p is to go from m to a, and then a to c and c to p. It's quite easy to track following around the shape. We know m to a is going to be a half of little a to c we know is 2b, and then c to p, well, the question says is k lots of a to c. Well, we know that a to c is 2b, so it's going to be k lots of 2b. This is the k that we're searching for the question. So we've got a half a. I'm going to factorise out the b's, so it's going to be 2k plus 2 lots of little b. That just makes my life a little bit easier later on. Okay, so the alternative way of getting from m to p, well, we know that m and p is a straight line, so it's going to be a scalar multiple of m to n. I'm going to call that scalar multiple j. So m to p will be j lots of m to n. Now, my path from m to n is to go from m to a, and then a to c, and then c to n. M to a is going to be a half a to c is going to be 2b, and c to n is going to be 3/8 of c to b, because the ratio is 3 to 5, so it's 3/8 of the way along from c to b is c to n. Now, where I've got c to b, that's why my little aside earlier, we know that c to b is minus little a plus little b, so I can replace c to b with minus a plus b there. And now I'm just going to expand that out and tidy it up. So we've got a half a, we've still got j lots of all of this, but a half a plus 2b minus 3/8 of a plus 3/8 of b. And all of that, collect the a's, collect the b's, we're going to have 1/8 of a plus 9/8 of little b. And at this point I'll expand out the j. It doesn't really do a lot, but it allows me to write these as multiples of little a and multiples of little b. So we get 1/8 j lots of little a and 19/8 j lots of little b. And that is m to p in an alternative way. Now, we know the 2 ways that we've constructed m to p, they construct the same vector, so they are the same. And so the number of little a's is going to be the same, and the number of little b's is going to be the same, because they're the same vector. So I mean, look at the little a's there. We've got a half on the first one, and we've got an 1/8 j on the second one. So an 1/8 j must be equal to a half. Times both sides by 8, that means that j in this case is going to be 4. Then comparing the little b's, we've got 19/8 j at the bottom there, and we've got 2k plus 2, lots of little b in the top. Those must be the same as well. So 2k plus 2 will be equal to 19/8 of j. Now we know that j is 4, so 2k plus 2 will be 19/8 times 4. If you prefer 19/2, just cancel the 4 with the 8 to make it the 2. And at this point we're just solving to find k and answer the question. So I've multiplied everything by 2 to get rid of the fraction, subtract 4 from both sides, and lastly divide by 4 to get k to be 15/4, 15 over 4, or anything equivalent is fine. Well done if you managed to get that one. Alright, bye.